Hello, this is Erica Ambrioso, and this is my Neural Networks Project number 3 presentation. So, for this project, I decided to try to detect botnet activity based on network traffic files. So, the dataset that I used is called the CTU13 dataset, and it's made up of 13 different scenarios. And each one contains normal activity, background activity, and botnet activity, and it's labeled pretty well. And like I said, there's 13 different scenarios. I ended up just using scenario number 9, and I'll kind of show why I used that one. But the data was recorded by recording the PCAP files during a time period, and then those were turned into what's called bi-directional net flow files. So NetFlow is a protocol developed by Cisco, and it just kind of gives a better picture of the traffic flow, um, and it works pretty well to feed into a neural network. Um, okay, so the first thing I did was kind of try to play around with the data set and understand what was going on. So I took three of the files. I took 8, 9, and 10, or three of the scenarios. Um, and so I printed out the shape, a couple of data points, and then I printed out the number of normal data points and the number of botnet data points. And you can see with scenario 8, there are a ton of normal data points and only like 6,000 botnet data points. And I figured this probably wasn't going to be good enough to get a good to help the neural network learn well. So then I did the same for scenario 9 and 10, and 9 and 10 are better distributed. 9 was even better than 10, so I went with 9. So you can also see some of the what you call them, field names here: start time, duration, protocol, and all kinds of stuff. It also includes the source and destination IP, and the direction and everything. So, like I said, I went with scenario number 9, and then I loaded the dataset into a pickle file because I guess that's can help with faster loading. So I extracted these features here, and put them in a pickle file, and then I label for background and normal gets a 0, and botnet gets a 1. And then I played around with a lot of different numbers for how big the training and the testing data set were. Right now, this one looks like it's at 5,000, or actually 5,000 true botnet points and 5,000 normal points. So 10,000 for the training, and then 5,000 for the testing. But like I said, I played around with some different ones. So then I found this actually on someone's GitHub, and I made some changes, and I talk about what changes I made to it up there. So then I printed out some things again just to make sure the data was consistent and make sure I understood what was going on. So you can see the shapes and you can see the data points. So this first one is the timestamp, and that one's obviously not in a computer readable really format, but I remove it later on, but I needed it to kind of decide how I was going to build the sequences to feed it into an RNN. So I printed out the times here, and actually these times I don't think match up with these. This was kind of like a lot of playing around. This was like for the an original like time recording. But anyways, so it's only over a couple of hours, and it all occurs on one day. So I decided to use a window size of 100. Um, and then I wrote this function to create the sequences. This is really similar to what was done in class. Um, and then I create the sequences, and I printed out the shapes just to make sure we're all good. Um, and then I built the model. So I used a bidirectional LSTM with 64 units and some dropout, and then I have a fully connected layer. You can see the summary here. And then I went ahead and fit it. I have a pretty big batch size. I tried a smaller one, and it took a really long time. I tried bigger as well, but I found that 256 worked pretty well. It still was not super fast, but I let it run. Um, and then I plotted the loss. You can see it definitely goes down. Um, and then I went ahead and tried to figure out how accurate it was and how well the predictions were. So I printed out a couple of the sequences and I printed out the predictions, and you can see it gets some things right in here. And here it gets not really sure what's going on, but it kind of knows there's some botnet points in there. Same thing here. It's off a little bit. I also noticed that the predictions were a lot of times putting in these botnet points at the very beginning of the sequence. I am not really sure why, but there's definitely some sort of error because you can see that the real ones don't really have it there at the beginning, but the predicted kind of thinks there is. Um, so I got kind of stuck here. I didn't really know what to do. I tried using some more training and testing to see if that would help. So this is with 30,000 training and 15,000 testing. And I did the same stuff where I used the pickle file and everything and build the sequences. And then I fit the models again to the RNN. And let's see. Again, you can see the losses going down. It's kind of plateauing here. Maybe could have gone down if I did some more epochs, but it was taking like 40 seconds per epoch, so it was kind of a long time. So then I went ahead and printed these out again, and it's predicting these ones at the beginning for some reason. And this, honestly, to me, this one seemed to be doing even worse. It was really hard to figure out what was going on. I have this threshold value here, which is what determines for the predicted values because they were actually like decimals and stuff. So it determines like what decimal is a true or false. And I played around a lot with this value. In the earlier one, I think it was 0.1, which worked pretty well. But here I had to bring it down, and it wasn't very good. I don't know how I could have gotten a better measure of the accuracy for an RNN like this. So my closing thoughts are, I'm not very happy with these results. I don't think I understood how the LSTM model was really working and how I can get an idea of the accuracy or anything like that. So not super happy with these results. But I would say that this first one up here it was learning to some extent. Like it figured out some things. It wasn't great, but it definitely was figuring stuff out. And so then I decided to try running it on a simpler model because I kind of felt like maybe this data wasn't the best for an RNN because RNN is really kind of like time dependent data, and a botnet attack could really occur at any time. So I think it maybe didn't matter the time sequences and everything. So I went ahead and removed the timestamps and scaled the data and ran KNN on it. I just used the sklearn KNN classifier, and I printed out the prediction, and it did really well. I was a little upset that I spent so much time trying to figure out the RNN when really just a very simple model performed well on it. So that's kind of all I have. I think that, like I said, the data just wasn't really good for an RNN. I probably should have used something else. So yeah, that's my project.